Good afternoon to all. This is Kamal Kishor Sharma, Senior Lecturer, Department of Mechanical Engineering, IIMT College of Polytechnic, Greater Noida. Today, I am discussing about introduction about applied mechanics, and here we are discussing about what is mechanics and what are the different branches of mechanics and basic fundamental about mechanics and in the definition of mechanics, it is the branch of science which deal with study of forces and their effect on the body at which force act. Mechanics is the also known as science of forces. मैकेनिक्स विज्ञान की वह शाखा है जिसमें बल और वस्तु पर बल के प्रभाव का अध्ययन किया जाता है. Mechanics is divided into two parts. One is statics, another is dynamics. So in the statics, where we study about the object which are under the condition at rest, and in the dynamics, the branch which deal with the study of forces acting on the body under the condition in motion. So here different branches of applied mechanics or engineering mechanics. So some branches like mechanics of solid, where we study about rigid body, and mechanics of deformable body. In the rigid body means the body which have no effect of force, and the branch is divided into statics and dynamics. Here statics means branch of science where the body is at rest, and the dynamics we are previously discussed, the body is in motion. So also divided into kinematics and kinetics, which we further discuss. And here the mechanics of deformable body, where we study about theory of elasticity, theory of plasticity, and another branch of mechanics of fluids, where we study about ideal fluid, viscous fluid, incompressible fluids, and the two another branch of mechanics like kinetics and kinematics. Kinetics, the study of cause of motion of the object, where mass of the object taken into consideration. So in the kinetics, we study for the application in the design of automobiles where force is considered, and in the kinematics, study of position, acceleration, speed of an object, the mass of object is not taken into consideration. So बल के प्रभाव में वस्तु का अध्ययन करते हैं और बल के प्रभाव के बिना वस्तु का अध्ययन करते हैं. तो यहाँ पे केवल शुद्ध गति विज्ञान और बल गति विज्ञान इस तरह से इन्हें डिवाइड किया गया है. Next, some other branches of mechanics such as thermodynamics, where we study the relation between heat and work, temperature and energy. In gas dynamics, we study the dynamic property of gases and their thermal effects. Hydrostatics, where this is a subcategory of fluid which is study all type of fluid, both compressible and incompressible fluid, which is at rest. Hydrodynamics, the branch of dynamics which deal with the motion of fluid and the force acting on solid body, immersed in fluid in motion, a relation of them compared to hydrostatics. And aerodynamics is another branch of dynamics which deal with study of forces of air in motion. There we are discussing what is the utility of mechanics. So in the field of engineering, in the daily life, we have to use applied mechanics. The knowledge of applied mechanics is very essential for an engineer so that it can design and execute different structure of machine, which different structure used in bridges, internal, in the structure like frame which is used in railway bridge, nature of material, effect of mechanism. Seat belt in the car is an example of four concept of inertia, and banking of road. रोड के जो किनारे होते हैं and railway tracks are an example of uniform circular motion. So previously we are discussing what is rigid body. A rigid body is one which does not change its shape and size. Rigid body, दृढ़ पिंड वह वस्तु या वह बॉडी होती है वह जिसकर बल लगाने पर उस पर कोई प्रभाव नहीं पड़ता है या उसके साइज में कोई चेंज नहीं आता अंडर द इफेक्ट ऑफ फोर्स एक्टिंग ओवर इट. द in the rigidity of a body depend upon the fact that how far it go under deformation and under the effect of force acting on it. In the real sense, no elastic body is perfectly rigid. कोई भी elastic body perfectly rigid नहीं होती because every body change its shape and size under the force acting on it. Actually, the deformation in rigid body is very small or negligible. So we also study what is scalar or vector quantity in the mechanics. The scalar quantity everybody know sometime known as scalars. So that have only magnitude such as length, mass, time, distance, volume, density, speed, and temperature. So scalar have only magnitude, no direction. But unit vector, the vector whose magnitude is unity is known as unit vector and equal vector. Vectors which are parallel to each other, जो एक बराबर हों, जो एक जैसे हों एंड हैव सेम डायरेक्शन, एक ही दिशा में लग रहे हों, सेम सेंस, उनका मीनिंग भी वही हो, एंड इक्वल मैग्नीट्यूड आर नोन एज इक्वल वेक्टर. लाइक वेक्टर विच हैविंग पैरेलल टू ईच अदर एंड अनलाइक वेक्टर इसके अपोजिट होता है जो कि डिफरेंट डायरेक्शन में फोर्स लग रहा है. नेक्स्ट, there are fundamental quantity and derived quantity. So the quantity that does not depend on any other physical quantity for their measurement known as fundamental or basic quantity. These quantity cannot be expressed in terms of derived unit. These quantity cannot be further reduced to the elementary level. So derived quantity जिसे ड्राइव किया जाता है, जैसे फोर्स का फॉर्मूला होता है मास इनटू एक्सेलरेशन, द प्रोडक्ट एंड रेशियो ऑफ द फंडामेंटल क्वांटिटी. फंडामेंटल क्वांटिटी का प्रोडक्ट ड्राइव क्वांटिटी कहलाता है. क्वांटिटी कैन बी एक्सप्रेस्ड इन टर्म ऑफ फंडामेंटल यूनिट रिड्यूस्ड टू देयर एलिमेंट्री लेवल which composed to fundamental unit. So here some SI unit, metric system, जैसे time which are right in seconds, length right in meter, mass is in kilogram. So all these are SI unit. Temperature is in Kelvin, electric current is measured in ampere, luminous intensity, amount of substance measured in mole. These there are large number of derived unit which exist in the metric system. So derived unit such as heat, force, force into is equal to mass into acceleration, power, momentum, and acceleration. So fundamental and derived quantity right in this table. Base quantity or derived quantity. Base quantity or fundamental quantity also known as length, mass, time, temperature, and electric current. And these are the SI unit. Length which is measured in meter, mass is in kilogram, time is in second, and temperature in Kelvin, and electric current is in ampere. So here derived volume, length, width, and height. Yeah, length, width, or depth. So volume is in meter cube, cubic meter. Density, mass per unit volume. So kg, meter minus 3 power, and velocity, mass meter per second, and here force Newton, acceleration meter per second square. So some definition related to mechanics. First one is body, the part of matter which occupies some space, जो जगह घेरता है, जिसके पास मास होता है, जिसका फिक्स वॉल्यूम होता है, उसे हम बॉडी कहते हैं. पार्टिकल, कण. A body of negligible dimension, जिसकी डायमेंशन नेग्लिजिबल होती है उसे पार्टिकल या कण कहते हैं. स्पीड, speed is a scalar quantity. It is defined as distance per unit time. Velocity, it is displacement per unit time, but is it vector quantity because direction is fixed. Acceleration, that it is defined as a rate of change of velocity. So unit is meter per second square. वेग परिवर्तन की दर को त्वरण कहते हैं. Path of motion, if the successive position with time of any particle, किसी भी पार्टिकल की सक्सेसिव पोजीशन, लगातार उसकी जो पोजीशन है उसको ज्वाइन कर दिया जाए तो एक स्ट्रेट लाइन बन जाएगी. जिसे कहते हैं पाथ ऑफ मोशन. So there are three type of motion: rectilinear, curvilinear, and rotational motion. So here we are discussing state of motion. There are two types. One is state of motion, but one of state of rest. किसी भी बॉडी की दो ही मोशन, दो ही डायरेक्शन, मतलब जिसमें वो या तो रेस्ट की अवस्था में रहती है या वो मोशन की अवस्था में रहती है. व्हेन अ बॉडी चेंज इट्स पोजीशन विद रेफरेंस विद टाइम, टाइम के रिस्पेक्ट में, विद रिस्पेक्ट टू टाइम, अनदर एज्यूम्ड बॉडी, दो बॉडी को यदि कंपेयर किया जाए और टाइम के रिस्पेक्ट में यदि वो अपनी पोजीशन बदल रहे हैं, तो उसे हम कहेंगे स्टेट ऑफ मोशन. And opposite to that, if anybody does not change its position with respect to other assumed body, then it is called state of rest. Concept of force. Force is an external influence which can change or tends to change the position of a body. Action of one body to another when it is push or pull called force. फोर्स एक एक्सटर्नल बल, एक बाह्य कारक है जो किसी वस्तु की अवस्था को बदल सकता है यदि वो दूसरी बॉडी के सापेक्ष है. तो एक्शन ऑफ वन बॉडी, एक बॉडी की यदि दूसरे बॉडी पर एक्शन हो रही है, लाइक पुल कर रहे हैं, पुश कर रहे हैं, तो बल लगाकर उसकी स्थिति में परिवर्तन किया जा सकता है. इफेक्ट ऑफ अ फोर्स. फोर्स का क्या इफेक्ट होता है? इट कैन स्टॉप अ मूविंग बॉडी. बल लगाकर एक मूव कर रही बॉडी को रोका जा सकता है. इट कैन मेक अ बॉडी विच इज एट रेस्ट. इट कैन मूव अ बॉडी विच इज एट रेस्ट. यदि कोई बॉडी रेस्ट में है तो बल लगाकर उसे गति की दिशा में किया जा सकता है. इट कैन चेंज द डायरेक्शन. बल लगाकर डायरेक्शन को भी चेंज किया जा सकता है. इट कैन चेंज द शेप ऑफ अ बॉडी. किसी भी बॉडी के शेप को भी बल लगाकर चेंज किया जा सकता है. करेक्टरिस्टिक्स ऑफ फोर्स. देयर आर फोर करेक्टरिस्टिक्स. वन इज मैग्नीट्यूड. फिक्स मैग्नीट्यूड होता है फोर्स का. डायरेक्शन, फोर्स लगाने पर बॉडी एक पर्टिकुलर डायरेक्शन में मूव करती है. सो अनदर थर्ड पॉइंट इज पॉइंट ऑफ एक्शन. किस पॉइंट पर फोर्स लग रहा है, मतलब हमारा बल किस बिंदु पर लग रहा है, क्रिया किस बिंदु पर है, बल की क्रिया रेखा किस बिंदु पर है, लाइन ऑफ एक्शन. और किस दिशा में बल लगाया जा रहा है, उसकी क्रिया रेखा. तो मास, अमाउंट ऑफ मैटर ऑफ अ बॉडी, जिसे हम द्रव्यमान कहते हैं. वेट, द फोर्स विद विच अ बॉडी इज अट्रैक्टेड टुवर्ड द सेंटर ऑफ अर्थ, जिस के द्वारा वस्तु को बल लगाकर पृथ्वी के केंद्र की ओर खींचा जाता है, उसे उसका वेट कहते हैं. मास इनटू एक्सेलरेशन. टेंसाइल फोर्स. देयर आर टू टाइप ऑफ फोर्स. वन इज टेंसाइल, वन इज कंप्रेसिव. इफ वी पुश द बॉडी towards outside, so then this is called tensile force. The force which tends to increase the distance between the particle of a body. So tensile force, yeah, tension force. Compressive force, the force which tends to decrease the distance between particle. यदि हम पास ला रहे हैं, अंदर की ओर दबा रहे हैं, तो बॉडी के पार्टिकल जो होंगे उनके बीच की जो दूरी होगी वो घट जाएगी. उसे कंप्रेसिव फोर्स कहते हैं. एक्टिव फोर्स, फोर्स अप्लाइड ऑन द बॉडी. यदि हम किसी बॉडी पे फोर्स लगाएं, दैट इज एक्टिव फोर्स. रिएक्टिव फोर्स, फोर्स डेवलप ड्यू टू एक्टिव फोर्स. एक्टिव फोर्स की वजह से जो फोर्स डेवलप होता है उसे हम कहते हैं रिएक्टिव फोर्स. ऐसा कि यू कैन सी इन दिस पिक्चर the book having action on the table, and there is reaction from the book by the table. So one is active force due to weight of the object, another is reactive force from the opposite to the active force. Here you can see, if you pushing, so you have take support by the ground, and if you move a rock, so you can also exert force on ground. So this is action force, this is also an action force. So action इक्वल एंड अपोजिट होती है, जबकि आपका रिएक्शन जो आता है एक्शन की वजह से आता है. सो रिएक्शन पैर से इधर की ओर हो रही है और एक्शन इधर की ओर हो रही है. एक्शन क्या हो रही है कि ये जो रॉक है आगे की ओर बढ़ जाएगा क्योंकि इसे पैर लगाया हो गया. So in the everyday sense, the term work means to do something that take physical or mental effort. In the terms of physics, we work has different meaning. Work is done on object when a force causes a displacement or of the object in the direction of force. There are different example of work done in our daily life, like in a school football match when a boy hit the ball or do any other player. A batsman hitting a ball during a cricket match, and a compressed spring when released do work on ball. So there are some example of a man pushing a box and moving it the location A to B. So this is initial position and this is final position. Change in the position or displacement from A to B. So there are some example of work. And in pressure is equal to force per unit area. Force per cross sectional area is called work. So pressure pressure is defined as force per unit area. Here same force, same different area and different pressure. We have to put the value F upon A in this pressure formula. So pressure unit is Pascal, force unit is Newton, or area unit is meter square. The unit of pressure is Pascal, and 1 Pascal is equal to 1 Newton per meter square. So here we put weight and the same force, by the same force in different area we have found different pressure. So power, it is another terms which is work per unit time. Power, work is equal to force into displacement. So power is equal to force into displacement upon time, or displacement upon time is also known as velocity. So power is equal to force into velocity. So pressure in the physical science, the particular force per unit area or stress at a point with confined fluid. Here we can see by the image the force applied perpendicular to the surface of an object per unit area over which that force is distributed. Here we can learn some terms, different type of load and different type of forces. So here we can see point load or concentrated load, and here we can see uniformly distributed load UDL, which is one end which having roller support, another end which is fixed support and roller support. So this is uniformly bearing load. So different three type of load are there. There are 3 point load W1, W2, and W3, and they are at different distances from both the ends. Here UDL force is uniformly distributed throughout the beam, and here uniformly bearing load is vary from point to point. Example of beam, different type of beams. Simply supported beam is one of that. Rest on two supports is free to move horizontally. Typically, practical application of simply supported beam with point loading including bridges, beam in building, and beam of machine too. So here the simply supported beam here support like a bridge, we have C in concentrated load, and UDL uniformly distributed load UDL. So example of beam is a railway bridge on the river. So we can study what is system force systems. So system of force tell us arrangement of force which is classified as coplanar force and non-coplanar force, concurrent force, parallel force. And what is force? It is an agent which produce or tends to produce, destroy or tends to destroy motion of body, which is called force. Unit of force is Newton and it is a vector quantity. So there are system of force. These are coplanar forces like in a same plane. Non-coplanar, non-coplanar means forces in different plane. Coplanar but non-concurrent. Forces are coplanar and concurrent. Forces coplanar तो हैं but different point से इनका origin हो रहा है. These are called non-current. And here is collinear force in the same line. Coplanar and parallel force. So forces like parallel and unlike parallel. So in these forces, there is a law which is law of parallelogram, which we studied about under force analysis. So according to this law, if two forces acting at a point can be represented in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant is represented in magnitude and direction by the diagonal of a parallelogram. So here P and Q are the two forces which are acting at point O, and COC is the resultant which is represented by R. OA is represented by P and OB which is represented by Q. So P and Q, P is the magnitude of vector P, Q is the magnitude of vector Q, and which is represented by OA and OB. R is the magnitude of resultant vector, and alpha direction between two forces, angle between resultant vector, and theta is the angle between two vectors which is given. So one of them is Lami's theorem. Here, if the three forces coplanar, concurrent and collinear are acting at a point or a particle that keep the bodies in static equilibrium, then each force will be proportional to sine of angle between rest two forces. So here Lami's theorem, which is the sine if three forces are acting at a point, three concurrent or coplanar forces are acting at a point are in equilibrium, then each force is proportional to sine of angle between rest two forces. So here in the conclusion, in the Lami's theorem, I will in the Lami's theorem we can calculate different forces acting on different, like one is tensile force, one is compressive force, or a string fixed with the wall, and so on, and a bulb is moving down and fixed with a string with a ceiling, and one person is pushing the string on his side. So different type. So at the end, I am going to conclusion. I believe that mechanical engineering too vital of field to be dropped from curricular due to its importance to the university and to the world. Mechanical engineering has intervened throughout the making of our history, and it is backbone of almost everything that we used on a daily life. Thank you.